Okay, we're going to be talking about algebraic expressions and how to simplify them. So this is 020018. It's module 2 continued. Whoops, sorry, it's 0028. And it's module 2 continued. And we're going to be talking about simplifying algebraic expressions. Again, remember I've mentioned before, an expression and equations are different. We'll be talking about equations later on in this class, but right now we're just talking about expressions, meaning that the problem doesn't have an equal sign. Okay, so we're only going to be simplifying as much as we can. So let's talk about a couple definitions. An algebraic expression is the sum of one or more terms. Okay, so you say, well, what's a term, right? So let's define what a term is. A term is a constant, meaning it's a number, or a product, or quotient of constants and variables. Okay, remember we talked about a variable. It's basically a letter. We represent those with letters because the quantity can vary. And then finally, our constant is simply a number, right? It's a fixed number. Okay, so an example of a term, you might say 7y negative 2ab, right? These are all terms. So if we talk about an expression, an example of an expression, something like negative 7x squared plus xy minus 100. Okay, each one of these are separated by an addition or a subtraction, right? So our terms for this expression are negative 7x squared. We also have the term xy and negative 100. These first two terms, because they have a variable in there, we call them variable terms. And this last one here, negative 100, is simply a constant term. No letters in it. Okay, so now that we understand the concept of terms, we need to define what we mean by like terms. Meaning they have the same variable part. So these are terms that have the same variable part. Okay, so for example, two like terms, we have, say, negative 5x and 3x. Those are alike because we have one x in there. Unlike terms would be, say, negative 5x and 3x squared. Okay, granted, we have, they both have the letter x in them, but if you notice, this has just one x, right? And this has an x squared term. So those aren't the same. Okay, we could also have 2ab and 0.7 ab. And some unlike terms would be, say, 2ab squared and 2a squared b. Right? These are not alike because the variable part for this is just ab squared, and that's not the same as a squared b. Okay, so be very careful about what we consider a like term. Okay, let's do a couple more definitions. Okay. So we want to talk about a coefficient. We're going to use that term a lot. And that's all that is the number that's with the variable part, variable term. Okay, so remember, we have, say, 7x squared. It's a variable term, and 7 is our coefficient. If I have negative 3a squared b, negative 3 is my coefficient. So let's just kind of go through a couple examples here. If I'm given this expression, given 4xy minus 9x squared plus 15, how many terms do we see? We should be able to spot how many terms. Oops, how many terms? Well, I see 3 terms, right? There's 3 things that are separated by addition and subtraction. So I see 3 terms. And what are they? So my terms are 4xy, negative 9x squared, and 15. And what are the coefficients? Well, for this one, it's 4. For this one, it's negative 9. And the last one, simply 15. And if you notice, the sign for negative 9x squared went along with it. Because again, if you remember, we can always rewrite a subtraction as a addition of the opposite, right? So now if I look at my various terms, I have this one, I have this one, and I have that one. Okay, let's do another one. Given 2a minus b plus c minus 80. Okay, so what are the terms? How many terms do we see first? Right, we have 4 terms. And what are they? I have 2a, I have minus b, I have positive c, and I have a negative 80. And what are their coefficients? Well, remember I said that the coefficient is the number, right? That's with the variable term. First one's easy, right? It's 2. But what about the second one? Well, if I don't see a number out here, that's the same as negative 1b. Same with this one. This is positive 1c. Okay, so if I don't see a number out there in front of it, it's understood that my coefficient is 1. In this case, it's negative 1 because it was a negative b. This is a positive 1c. And then 80 is not really a coefficient, but it's the constant term. Okay, let's do a little more practice. See whether or not we can identify like terms. So are 5x cubed and 5x like terms? The answer is no. And why not? Well, because the variable parts, right, the variable parts are x cubed and x, right? So x cubed and x are not the same variable parts. Okay, how about our negative 7y squared and 11y squared like terms? Well, sure enough, if you look at my variable parts, right, I have a y squared here and a y squared there. So the answer is yes. Are 2m squared n to the 5th and 3m to the 5th n squared like terms? And then here the answer is no. And sure, we have m and n, but if you notice, this m is to the 2nd, this m is to the 5th. So automatically you know that they're not the same, right? So m squared n to the 5th and m to the 5th n squared are not alike. Okay, so you have to be very careful about what we identify as a like term. Okay, so let's do a couple examples. So let's use the distributive property. To add like terms. So if I have 8x plus 3x, right? When I have 8 x's, it's like saying I have 8 apples and 3 apples. So you simply add the coefficients. So I get 11x. And you can think of it using the distributive property as 8 plus 3 x's. Right? What if I have simplify negative 6a plus 4a plus a. Right, again, we have all a's, so that's okay. And what's the coefficient of the last a? Remember, if we don't see anything there, we assume it's a 1. Okay, so I can think to myself, well, that's just negative 6 plus 4 plus 1. And those are all a's, right? So I have negative 6 plus 4 is negative 2, plus 1 is negative 1. So it's just negative 1a, or I can simply write it as negative a. Okay, and we'll do a couple more examples in the next video.